Okay, so let's take a look here at example number 1, using the distributive property to factor a polynomial. So we're going to take this polynomial, 12a squared plus 16a, we're going to factor it. So first we're going to factor each term. Remember that factor just means to break it down into all the numbers that you would multiply to get to that number. So if we think about the 12 first, 12 can be factored in a few different ways. You could take 12, you could break it into 12 times 1, you could break it into 6 times 2, 3 times 4. We are going to start with that bottom one, 3 times 4. And we are then going to break up the 4 into 2 times 2. Okay. Now, let's say we went with this other one, 6 times 2. Well, 6 times 2, the 6 can break down further into 3 times 2. So then we get 3 times 2 times 2. Same thing that we got here, 3 times 2 times 2. Same thing that they here have right here, 3 times 2 times 2. Okay, so that was completely factored down. We could say times 1, but we don't really write the times 1 part. Now, a squared here, that breaks down into a times a. Just use my mouse for this. If we wanted to factor 16a, well, we're not going to factor anything out of the a because it's not a squared. You can't break that down. We just have a there at the end. And 16 breaks down to 2 times 2 times 2 times 2. 2 times 2 would be 4, times 2 is 8, times 2 is 16. Okay, so we've completely factored this down. What I'm showing you here, by the way, is kind of the longest way to do these problems. So when you get comfortable with this, you probably won't take this many steps to do it. You might just look at 12 and 16 and kind of come up with the answer. But let's go through the steps. So underline the common terms. Well, common to both 12a squared and to 16a was a 2, and an a, right? A 2, and an a. The bottom one had more 2's, but the top one did not. So we're only saying that these 2 2's were common in both, and one of the a's were common in both. This second a, there was not a second a in the next one, so we wouldn't say both. We wouldn't say all of the a's are common. These ones are common, and these 2 pairs of 2's. So what do we get when we have our 2 times 2 times a? Well, 2 times 2 is 4, and times a. So 2 times 2 times a, or 4a. Okay. So that would be our greatest common factor of these two would be 4a. If you were just looking at these, you could think that the biggest number that I could divide both of these numbers by is 4. You know, I could divide them both by 2 evenly. That'd be fine. Don't think you can divide them by 3. So yeah, looks like 4 would be the biggest number you could divide them by. And the a portion, well, we have a squared and a. The biggest amount of a's that's common to both of these is 1a. Okay, so after you have gotten that greatest common factor, which in our case was that 4a, factoring says that what we just did was we did 4a times basically everything that was left. So what was left on the first part? There was that 3 and that a. So we had 4a times 3a. And what was left on the other one? Well, we had our 4a, our greatest common factor there, and what was left over was just that other 2 times 2. So it was just left over was 4. Okay, now we have that our polynomial has been factored, has kind of been broken down into 4a times 3a and 4a times 4. So if we have 4a being multiplied by 2 different things, another way to say that is that we have 4a times 3a and 4, right? We have 4a times 3a and we have 4a times 4. So we have 4a times 3a and 4. If you wanted, you could take your paper and draw this in an area model like we saw in our last video to kind of showcase what we're doing there. You could also stop if you would like to take a look and practice another one. So finding the greatest common factor here, what is common in these 3 rows. So they have 3 terms in this polynomial, 3 different numbers. And you can see that there's some common stuff in there, some x's. So it looks like there's 2 x's that are common. Looks like there might be a 5 that's common. So if you have 2 x's being multiplied and 5, your greatest common factor would then be 5x squared. Okay, so that's kind of what we'd be doing there. Okay. Now let me figure out how to turn this off.